2, 3, funky.
Hey you guys, welcome back to my channel, and I hope you guys having a good day. And today's video I'm going to be going over Newton's second law, and yeah, let's just get started. Okay, so we have to go over the basics like we did in the first law video, and basically the basics for this one is an object accelerates when a net force acts on it. So when there's a force that's acting on an object, it would move forward and accelerate and speed up. When a force is acting on an object, it can make it increase or decrease its speed or change the direction of the object that it's acting upon, if that makes any sense. The cause of acceleration is force, so force is the cause of acceleration, is the reason that objects accelerate, and acceleration is equal to the change in velocity over the time interval, and that's basically the definition of acceleration. So a change in velocity over a certain time period, and those are the basics. So basically, like, information we already know that we need to apply to this new unit. Okay, so the second law is a relationship among an object's mass, acceleration, net force of an object. So basically, you see how this guy has two thumbs up. Is directly proportional because they're the same, and if the two thumbs up are both going up, then they're both going up. I don't really know a good example other than it being the same thumbs up, and this is inversely proportional because if you move this hand up and move this one down, it would be going in opposite directions. Like, I don't really know how to explain it, but like, this is the same. So for directly proportional, it's the same, and inversely proportional means the opposite but in the same. So if you move both your thumbs up like 10 meters, it would both go up 10 meters, and this would go up 10 meters and this would go down 10 meters, like the inverse. Like, do you understand what I'm saying? Because I feel like I'm just talking. Anyways, so force is basically mass times acceleration. That is the formula as well. So mass times acceleration. The acceleration depends on the mass being pushed, and the acceleration is also inversely proportional to the mass. So basically, just like what I just said with the thumbs up and stuff, so acceleration would be like a thumbs up and mass would be the thumbs down. So if you increase acceleration by 2 times, your mass would go down to 1/2. So like the example I have for the second one says, if you have the same force, that's very important, if you have the same force but you double your mass, so the thumbs down, if you double that, it would result in half the acceleration, because what you do to one would inversely occur to the other one. So doubling this would lead to half of that. You feel me? So yeah, they're inversely proportional, and that's the relationship, inversely related. But here's some practice problem for his second law. So you have 4 newtons of force that's applied to two blocks. So there's 2 different blocks. One weighs less than the other. So this is 5 kilograms and this is 10 kilograms. So the question is, which one would accelerate faster? And so think about it. If you're applying the same amount of force to 2 different objects, one is way more than the other and one is less. Pushing a coin compared to pushing your phone with the same force, obviously the coin will accelerate much faster because the same force but to a smaller weight is your answer. So the same force but a smaller weight, the acceleration will be faster. You feel me? So yeah. Okay, so another problem, but in this case we have different forces, but now they're the same weight but different forces. So a red block and a yellow block have the same mass, but the red block is pushed with more force. Which one would accelerate faster? Obviously the red block would accelerate faster because you're pushing it with way more force. So the more force you apply to something, the faster it's going to accelerate. So that's just that on that. So So they might weigh the same, but you're applying more force to one of them, so that is the one that's going to move faster. Okay, so practice questions. When a net force acts on an object, its acceleration depends on the objects. And I said this in the beginning, and the answer is mass. So it depends on the mass. So as mass is added to a pushed object, its acceleration, does it increase or decrease? When you add mass to a pushed object, what does the acceleration do? So your object is getting heavier and heavier. What is going to happen to the acceleration if the force is constant? Obviously, it would decrease because it's going to move slower because you're adding more weight to it. So if you're now for number 3, if you're reducing the mass from the object, what would the acceleration do? Well, it would increase because it's literally the opposite question of number 2, and it would increase because your object is getting lighter, so it'll be easier for you to push it, so that means there's more acceleration. For number 4, as force is added to a push object, so you're adding more force and you're pushing it more and more, the acceleration is going to increase because force and acceleration have a direct relationship. So as force goes up, acceleration goes up. As force is subtracted, so you're taking force away from your object, its acceleration would decrease because again, it has a direct relationship. If this goes down, this also goes down. You're pushing a car at a constant acceleration, but you are getting tired. What change could you make to push the cart with the same acceleration but with only half the force? So I'm pushing a cart with a constant acceleration, but I'm getting tired. So what should I do if I'm going to have the same acceleration, but I want to only apply half the force? So obviously I would have to decrease the mass, so make the object lighter so it's easier for me to push it with the same acceleration. So yeah, these are the answers: mass, decrease, increase, increase, decrease, and decrease the mass. Okay, so these are formulas. So force is equal to mass times acceleration, and when you manipulate that to get what A and M equal to, so A is force divided by mass, and mass is force divided by acceleration. Force is newtons, for mass is kilograms, and for acceleration it is meters per second squared. Okay, so now we're gonna work through some practice problems from my teacher to just wrap this up. So this is the math aspect with the formulas and everything. So how much net force or thrust must a 30,000 kilogram jet plane develop to achieve an acceleration of 1.5 meters per second squared? So they gave you the mass, which is 30,000 kilograms, and they gave you the acceleration, so 1.5 meters per second squared, and they're asking you what is the force. And so force we know is mass times acceleration, so when you plug that into its place in the equation, you would get 45,000 newtons because you just have to multiply. So the next problem: a car has a mass of 1,000 kilograms. What is the acceleration produced by a force of 2,000 newtons? And so in this problem, you are given newtons, which is the force, and you are given kilograms, which is the mass. So you have to solve for acceleration. So acceleration we know is force divided by mass, and 2,000 divided by 1,000 will give you 2 meters per second squared, and that's your acceleration. The last problem is an object is pushed with an acceleration of 5 meters per second squared, so we have acceleration, and a force of 15 newtons, so we have the force. What is the mass? And we know that mass is force over acceleration. So 15 divided by 3, you will have 3 kilograms for your mass. And that's it. Also, I came across a problem where they asked me for the force or something, I believe, and for the problem they didn't give me acceleration. What they did give me was the velocity, and in the problem they made it clear that it had a constant velocity, so that means there was no acceleration, and so your acceleration would have been 0. So make sure you watch out for word problems like that where it specifically doesn't give you m over s squared and it just gives you the m over s. So be careful with that because they could trick you and your answer would actually be 0. So yeah, read carefully, and that's it for the video. Thanks for watching, and I hope you found this video helpful, and I will see you guys in the next one. Bye guys. So basically it is direct I need a moment to breathe. So when you're adding mass to an object, hold on, I'm out of breath. I'm talking way too fast. And force the unit for oh my god.